exercise 6.2. First question I copied and I have kept here. There are two figures. From the figures 1 and 2, DE is parallel to BC and find EC. In both the figures you have to find out EC. In both the figures DE is parallel to BC. So let us find out DE. DE is parallel to BC. Better you put a parallel marker symbol. And here also DE is parallel to BC. Now whenever there is a parallel side to one parallel line to one side, you can apply basic proportionality theorem. Now you have to find AC in 1 and AD in 2. That means AC is complete side. Okay. So now let us say BPT. Let us apply BPT simultaneously in both the figures. So now AD by BD is equal to AE by CE. Now this is the in this also the same. AD by BD is equal to AE by CE. So now AD is given 1.5 centimeters. I am not writing centimeters. BD is equal to 3 centimeters. And AE is equal to 1 centimeter. And I don't write centimeter. And CE is CE only. So cross multiply it. 1.5 CE is equal to 3 and CE is equal to 3 upon 1.5 is equal to 2. So CE is equal to 2 centimeters. Now let us work here. AD we don't know. Keep it like that. AD by BD 7.2 is equal to AE is 1.8 and this is 5.4. So now AD is equal to 7.2 into 1.8 by 5.4. So now you can do 18 table will go. 18 ones are 18 3 0.3 and this 0.3 will go in this 3 table 0.1 and 2 4. Okay, 0.1 will cancel and it is equal to 2.4 centimeters. Okay, so this is how you have to apply basic proportionality theorem in the figures. Let us go to the second question. Second problem goes as it is. E and F are the points on PQ and PR. In this diagram is not given. Let us draw the diagram. So I have maximum equilateral triangle and a right angle triangle. I will draw equilateral triangle only. Okay. So irrespective of the measurements. So let me name it PQR. Okay, triangle PQR I have drawn. E and F are the points on PQ. E is on PQ and F is on PR. So these two sides. Such that he has given, let us say this is E and this is F. Okay. Now I will join this. You have to state whether EF is parallel to QR or not. So this line is parallel to QR or not. This is converse of basic proportionality theorem. So now there are 3 bits given. Let me do first bit. So PE is equal to 3.9. I will write here 3.9 and EQ is equal to 3 centimeters and PF is equal to 3.6 centimeters and FR is equal to 2.4. Now let us check PE by QE. Okay, and PF by FR. If these two ratios are equal, then EF is parallel. That is the converse of basic proportionality theorem. A line table will go 8, 4 table also will go 0.9, and this is 0.6. Again 3 table will go 0.3 and 0.2. So point it is equal to 1.5. So false. That means these two ratios are not equal. Therefore, EF is not parallel. Therefore, EF is not parallel to QR. Like this, you do these two questions also. One bit I have done. Remaining 2 bits you can do by yourself. Okay. Let us go to third problem. Question number 3 goes like this. In 6.1 figure. Okay. So this is 6.18 figure. I have copied from the textbook and I have written there. So LM is parallel to CB. So let me write parallel marks. These two are parallel. Okay. And LN is parallel to CD. So I will put 2 arrow mark symbols. So prove that AM by AB is equal to AN by AD. So there are 2 triangles. One triangle upside ACB triangle. In this, LM is parallel to CB. So you can apply basic proportionality theorem. So then how it will go? AM by AB. You can take the converse of basic proportionality theorem, and AL by AC. This is converse of basic proportionality theorem. Not directly proportional, BPT, converse. If it is only BPT, AM, BM I should take. If it is converse, I will take AM and AB. Okay. So let us say this is the first equation. You take the down triangle also, A triangle ACD, and LN is parallel to CD given. So BPT you can apply converse of BPT here also. AL by AC is equal to AN by AD. So this is also converse of basic proportionality theorem. So now this is a second equation. In both the equations, AL by AC and AL by AC, right hand side of 1 is equal to left hand side of 2. So therefore, both other sides are equal. That implies AM by AB is equal to AN by AD. This is what we have to prove. Let us go to next question. So the question number 4 goes like this. Question number 4 goes like this. In 6.19 figure, so this is 6.19 figure. Figure is given. Whenever figure is given, it's easy for you to do it. And DE is parallel to AC. Let me indicate parallel lines. DE is parallel to AC. That means you can take ABC triangle, and DF is parallel to 2 arrow marks I will put. DF is parallel to AE. Don't get confused, single arrow mark and double arrow mark. So prove that so on. So BF by FE is equal to BE by EC. So for this I will take triangle ABC first. Triangle ABC. DE is parallel to AC. So you can apply basic proportionality theorem. Before that you have to apply BPT, or you need to apply converse. That you have to find out. So BF and EC, so smaller parts are only there. So let us apply BPT directly. So this is a PD by AD is equal to BE by CE. This is BPT, basic proportionality theorem, first equation. Now in second equation also, in triangle ABE and DF is parallel to A. This is what is given. Now apply BPT here. Here also BD by AD is equal to BF by FE. This is, we have applied BPT and this is second equation. So whether you know or not, you just apply basic proportionality theorem, you will get at least out of 2 marks you will get 1 mark. Okay. Now you just compare in both the things, AD by BD, BD by AD and BD by AD. Left hand sides of both equations are same, therefore right hand sides are equal. So that means BE by CE is equal to BF by FE. Okay. So BF by FE is one side and BE by EC is one side. So notation is different. Here FE is given and we have this is correct, and CE is given in the RTP EC are given. So both are okay. So you can write proved. Very, very simplest question. Don't get confused. Let us go to next problem. So this is fifth question. This fifth question also diagram is given, figure number 6.20. So this is figure 6.20 from the textbook only. So let me, DE is parallel to OQ. DE is parallel to OQ. You have to be very careful. Then you have to take the triangle PQO. And DF is parallel to, I will put 2 arrowheads, and OR. So now, and show that EF is parallel to, EF means this one, parallel to QR. Let us take one triangle first, triangle POQ, and DE is parallel to OQ. Okay, now we can apply basic proportionality theorem. So now PE by QE is equal to PD by OD. This is a basic proportionality theorem and first equation. Now go to the second equation, second triangle POR. In this, DF is parallel to OR. Therefore, PD by OD is equal to PF by FR. So this is also, I have applied a basic proportionality theorem, and this is second equation. Now compare both the equations. In this, PD by OD, and here also PD by OD. Right hand side of 1 is equal to left hand side of 2. Therefore, the other 2 sides are equal. So that means PE by QE is equal to PF by FR. That means EF, the line EF divides 2 sides of triangle PQR in same ratio or proportion. Therefore, by converse of basic proportionality theorem, EF is parallel to QR. This is what, how the proof goes. So let us go to the next. Here the question number 6. So in this also figure number 6.21. So here figure 6.21. Okay. Now let us understand the problem by reading it. ABC are the points on OP, OQ, OR. Okay. PQ are given. O is an interior point. O is an interior point. PQR is the main triangle. From O, OP, OQ, OR joined, and these A, B, C, these 3 points are on these 3 lines, such that AB is parallel to PQ. AB is parallel to PQ. And AC is parallel to PR. And show that BC is parallel to QR. That means the other one. Okay. Let us apply. Let us follow. Instead of thinking, you just follow. So now triangle OPQ you have to take, because in that only AB is parallel to PQ. You just identify which triangle, in which triangle line is parallel to side, one side. In that you can apply basic proportionality theorem. So then what happens? OA by AP is equal to OB by OQ. Sorry, OB by BQ. Okay, now I have applied directly basic proportionality theorem 1. If needed, I will apply converse also. First, let me complete this. Okay, so now take another triangle OPR. OPR triangle. AC is parallel to PR. So therefore, by BPT, you can apply BPT. So then OA by AP is equal to OC by CR. So let us say this is second equation. In both the equations, OA by AP and OA by AP are same. So left hand sides of both 1 and 2 are equal. Therefore right hand sides are equal. Therefore DB by BQ is equal to OC by, not DB, I am sorry, OB. It's looking like D. OB by OQ, BQ is equal to OC by CR. That means these two things are equal. That implies BC divides two sides of triangle OQR in same proportion. I'll write ratio. Therefore, BC is parallel to the third side, that is nothing but QR. This is what we have to prove it. So let us go to the next question. So this is 7th question using 6.1 theorem, basic proportional theorem. Prove that a line drawn through midpoint of one side parallel to another side bisects the third side. So now let us draw a triangle. Okay. Now no diagram given. Let me name it A, B, C, and prove the line drawn through the midpoint of one side. Let us take a midpoint of AB, D. That means AB is equal to BD, midpoint. So through the midpoint of one side drawn parallel to another side. So parallel to BC. It is meeting AC at E. At E, and this is parallel. And it bisects the third side. So now what is given here? D is midpoint. That means AD is equal to BD. And second one, DE is parallel to BC. And what we have to prove? E is the midpoint. That means you have to prove AE is equal to CE. Now there is a triangle ABC, and there is a side parallel to one side, DE is parallel to BC. Without thinking any, directly apply basic proportionality theorem. AD by BD is equal of AD, let me write BD. BD by BD. Don't write BD in the place of AD. It won't be only to cancel. I have written 1. So BD will get cancelled. Okay, this is given. So then what happened? Nothing will be there on left hand side. Cross multiply it. A is equal to CE. So that means E is midpoint of AC. This is what is to be proved. Let us go to 8th question. So this is the 8th question. Here also no figure. Figure is not given. Using 6.2 theorem, prove that the line joining the midpoints of any two sides is parallel to the third side. So this is 9th class theorem. Okay, but now here you have to apply basic proportionality theorem. For this we will draw a diagram, a triangle we will draw. So let us name it A, B and C. So now midpoints are given. D is midpoint, AD is equal to BD, and E is also midpoint, A is equal to C. So if you join it, you will be getting DE. Now you have to prove that this DE is parallel to BE. Now let me write the given. Okay, D is the midpoint of AB and E is midpoint of MB, means not member of parliament, midpoint of AC, sorry, this is not C. Okay, now RTP. DE is parallel to BC. Now don't apply, last year there is one theorem, don't apply that theorem. We will apply basic proportionality theorem in this. So now AD by BD, because D is the midpoint, AD BD are same points, AD BD is equal to 1. Okay, as D is equal to midpoint. In the same way, AE by CE is also equal to 1, because E is a midpoint. If it is a midpoint, these two parts are equal. So right hand sides are 1 and 1. Therefore left hand sides are equal. AD by BD is equal to AE by CE. So that means DE divides AB AC in same proportion, same ratio. Therefore DE is parallel to BC. This is how the proof of 8 will go. Only 2 more problems are there. These 2 problems I am not going to teach. They are very important, and for them please subscribe my channel and check back my old videos. Otherwise wait for my coming video, so that the proofs of those 2 videos will be available. So please subscribe my channel, share my channel and like my channel.